Okay, good morning, everyone. As discussed earlier, so today we will start with system of linear equations. And in system of linear equations, say if you have, is the screen visible? One of you, please respond.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Yes, sir.
So system of linear equation, m linear equations we have. So first of all, uh, a linear equation looks like this: a11, so some constant into x1 plus some constant into x2 up to xn. So as I can see, there are n unknowns: x1, x2, x3 up to xn. So these are n unknowns, and the first linear equation is a11 x1, a12 x2, a13 x3 up to a1n xn is equal to b1. So you can count the number of rows: a11, a21, a31, and am1. It means that I have m linear equations, and the unknowns are x1, x2, x3 up to xn. So the system of m linear equations in n variables is actually a set of m equations. So looks like this. So there are three cases. I mean, whenever you solve system of equations, so the system may have exactly one solution. Like if you simply take two lines and you're solving it. So either may they intersect. If they are intersecting, then there will be just one solution. If they are not intersecting, I mean they are parallel lines, then there will be no solution. And if in case the system, both the lines coincide, I mean then the system will have infinitely many solutions. So if a linear system has a solution, then it is called consistent. If they don't have a solution, then we say that the system is inconsistent. Okay. So what I have done is I have those coefficients a11, a12, a13. I can simply write them in the matrix form as this. So A is a matrix with the coefficient matrix, which we call it. So a11, a12, a13 up to a1n. Then a21, a22, a23 up to a2n. And the last row is am1, am2, am3 up to amn. And the variable column matrix is x1, x2 up to xn. So you can see that, I mean, if you multiply these two matrices A and X, what you are going to get: A11 will be multiplied to X1, A12 will be multiplied to X2, A13 to X3, and A1n to Xn. So when you multiply first row to this column matrix, you will get the first equation that we had earlier. So look at the first equation: A11 X1, A12 X2, A13 X3, A1n Xn equal to B1. So it is nothing but a different way of writing that system of equation. So what we have, this matrix, coefficient matrix. So for any system of linear equation, I can get this coefficient matrix, the vector of unknowns x1, x2 up to xn, and the right hand side. So I can write that system as ax equal to b. So any system of equation, I can write it down as ax equal to b form. So depending on this form, this is very important, which is up to this you have studied, I mean, in your 12th standard. But after this, you have this new definition. What does definition say? If you have a system of equation ax equal to b, then the augmented matrix for this system can be written like this. What do I mean by this? So I have the coefficient matrix, a straight line, and I'm writing the right hand side. Look, it has no any different, what you can say, significance, rather than you want to do the row operations and column operations. In your 12th standard, it may happen many times that you do the operations on the left hand side and you forget to do it on the right hand side. And many times it is very much difficult to handle the calculations on the right hand side. So just for the sake of simplicity, what we do is we write down the segmented matrix. Moreover, finding out the rank of augmented matrix will be easier in this. Okay, so whenever a system will have a solution or it will not have a solution, that will be found out using the rank of A. Rank of A will be the left hand side of this vertical line. So if you hide this part, which one? This part, which means that you just look at this left hand side part and you declare the rank. So rank of this part will be the rank of A. And if I look at the complete matrix, this one, then it will give me the rank of the augmented matrix. So as I said, when I want to talk about a system having a solution or not having a solution will depend on the rank of A and the rank of augmented matrix. So that is very important. So in one calculations, I should be able to determine the rank of A and the rank of augmented matrix. So what we are going to do, we'll just look at the left hand side part, this much part, and I can declare the rank of A. If I look at the complete matrix, then I can declare the rank of augmented matrix. Then if both are equal, it means that it will have a solution. If in case the rank of this part, left hand side, does not become equal to the complete matrix, rank of complete matrix, then I will say that the system has no solution. That's what I have in this chart we are showing. Say Ax equal to B is the system of linear equations, M equations, N unknowns. Now what happens is, if the rank of augmented matrix is equal to rank of A, look on the left hand side, if rank of augmented matrix is equal to rank of A, then system has a solution. That's all I can guess. Look, there are three guesses. It will have a unique solution, it will have infinite solution, or it will have no solution. So if the rank of augmented matrix is not equal to rank of A, then the system is inconsistent. If the rank of augmented matrix is equal to rank of A, then the system is consistent. Now, being consistent means it has a solution. So being a solution, there are two types. Whether it will have infinite many solution or it will have a unique solution. And how do we determine that? So the next two rectangles below it shows that if rank of augmented matrix is equal to rank of A and it is less than number of variables. In this case, how many variables are there? N unknowns. Unknowns are nothing but variables. N unknowns are there. So less than number of variables. So if this rank is less than n, then it will have infinitely many solutions. If rank of augmented is equal to rank of A and it is equal to the number of variables, then and then only it will have a unique solution. This is the complete criteria for checking out whether it has a solution or not. Finding out the solution, when it is inconsistent, there is no point. If it has a unique solution, then our simple 12th standard method will work. But what?
Excuse me, sir.
Yes.
Sir, many of the students are not able to join. They are texting in the group. So,
Okay. Fine. So what we were discussing, so if rank of augmented matrix is equal to rank of A, system is consistent, and if the rank is less than number of variables, it will have infinitely many solutions. If the rank is equal to number of variables, then it will have a unique solution. So this is the complete distribution, and I said that if it is inconsistent, there is no point in finding out the solution. I mean, the question ends here. If ranks are not equal, you declare that system is inconsistent, and that is over. If the ranks are equal and it is equal to number of variables, it has a unique solution that I can declare, and with that, you use the 12 standard method. What was the 12 standard method? That you rewrite the equations. So you get the upper triangular form there and you rewrite the equations, and then you find the values of the variables by resubstituting in the previous equation. That was the method. Same method can be used here. The only question is this you haven't discussed when it has infinitely many solutions. So infinitely many solutions, how to find out? So this is the complete, what you can say, method by which I can always find out the solutions. So write the system in matrix form. What is our matrix form? Ax equal to b. Once we get the matrix form, you write down the augmented matrix AB from the given system. Then, then what I will do? Reduce the augmented matrix to echelon form. The echelon form is the first form by which we were finding out the rank. I will quickly revise what is echelon form. So in echelon form, if there is a zero row, it is placed at the bottom. If you have a first non-zero entry of the next row has to be on the right hand side of the previous row. Okay, so you have to convert the augmented matrix to that form. The note states whatever I said in the previous slide. The first part, the left hand side part of that vertical line, I mean to say just this much part of this augmented matrix, the A part will give me the rank of A, and the whole matrix will declare the rank of augmented matrix. So there you, after you do that, you can conclude system as unique, infinite, or no solution. So if consistent, then rewrite the equation and find the values. Then if consistent, rank of a augmented matrix is equal to rank of A, which is less than the number of variables. So if the rank is R, then n minus R variables are free. What do we mean by free variables? Free variable is something that you can take any value. Like for you will understand this better when I will solve some examples. So what I will do is n minus R variables are free. Then I'll say take the first variable as u, second as v, and third as w, etc. And then whatever are the remaining variables, the values of those variables I can find in terms of UVW. So that is a complete idea behind this. Fine. So let's go for solving examples now. So there is a complete theory part of our system of equations. Now, example number 1. Solve the following system of equation. So what we have, x plus y plus z is equal to 6. Then we have x minus y plus 2z is equal to 5. 3x plus y plus z is equal to 8. And the last one, 2x minus 2y plus 3z is equal to 7. So the system of 4 equations and 3 unknowns. So I'll write down the matrix form of this. The matrix form is 1, 1, 1, 1, minus 1, 2, 3, 1, 1, 2, minus 2 and 3. Then you have this vector of unknowns x, y, z. And the right hand side that you have is 6, 5, 8, 7. There's nothing new in this up to this. Now, what we have to do, we have to write down the augmented matrix. The augmented matrix is, the augmented matrix is denoted by square bracket A, vertical line B. So the augmented matrix will be 1, 1, 1, 1, minus 1, 2, 3, 1, 1, 2, minus 2, 3. Vertical line, write down B is 6, 5, 8, 7. So R2, what we have to do, we have to convert the augmented matrix to echelon form. So R2 minus R1, R3 minus 3 times R1, R4 minus 2 times R1. What do we have? 1, 1, 1, the last one 6. So 1 minus 1, 0, minus 2, 1, minus 1, sorry, plus 1. 6, 5 minus 6 minus 1, okay. Now 0, minus 2, minus 2, minus 10, 0, minus 4, 1, minus 5. Look, in the next step, without making this 2 as 1, what I can do is I can make the below entry 0. So in some cases this might be possible without bringing 1 there. The below entries can be made 0, so I will use that. So R3 minus R2, R4 minus 2 times R2. So let's do this calculations. So the matrix will turn out to be 1, 1, 1, 0, -2, 1, 0, 0, -3, and these will be 6, -1, -9. The last row will be 0, 0, -1, -3. Again, I can see that the third row can be made 0 using fourth one. I mean, the third one is multiple of 3. Multiple of 4 by 3. So R3 minus 3 times R4. R3 minus 3 times R4. So the matrix that we get is 1, 1, 1. I'm skipping one step here. I will simply interchange third and fourth 2 immediately. So 0, -2, 1, -1. Then we will have 0, 0, -1, -3. The last row is 0. So I hope this is Echelon form. Now I want someone of you to tell me what is rank of A.
It's 3, sir.
3.
It's 3. And rank of augmented matrix.
3.
Rank of augmented matrix is also 3. So rank of A, the left hand side part of this vertical line, it is 3. And the rank of augmented matrix, the complete matrix, is also 3. So rank of A is equal to rank of augmented matrix is equal to 3. And what are the number of variables in our system? 4 or 3.
It's also
Sorry,
3,
3.
sir.
It's also 3,
3.
which is
Sir, 3.
equal to number of variables. So in this case, as per our chart, whenever the rank of A is equal to rank of augmented matrix is equal to number of variables, system has unique solution. System has unique solution. So once a system has unique solution, we need to find the solution. And how do we find out? Using our 12th standard method, what we do is we rewrite the equations. So multiply by x, y, z to the matrix and we'll get the equations. So rewriting equations. What we will have, x plus y plus z is equal to 6. Then minus 2y plus z is equal to -1. And minus z is equal to -3. So from the third equation, what we have, z is equal to 3. Put z is equal to 3 in minus 2y plus z is equal to -1. So we will have minus 2y is equal to -1 -3. -4, minus will get cancelled out, y is equal to 2. Put y is equal to 2, z is equal to 3 in x plus y plus z is equal to 6. So in that case, the value of x is equal to 1. So is equal to 6. The z will turn out to be 1. So what is our solution? So the solution is x is, uh, x is equal to 1, y is equal to 2, and z is equal to 3 is the solution. So this is a revision kind of thing. Now we'll go for infinitely many solutions. So example number 2, solve 2x minus y minus z is equal to 2. X plus 2y plus z is equal to 2. The third one, 4x minus 7y minus 5z is equal to 2. So first of all, the matrix form. The matrix form will be 2 minus 1 minus 1 1 2 1 4 minus 7 minus 5. I'll directly go for augmented, as you can do those calculations, and in augmented form what I have to do is I have to write the coefficient matrix, vertical line 2 2 2. Now bring 1 R12. So the new augmented matrix that I will get is 1 2 1 2. 2 minus 1 minus 1 2. Then 4 minus 7 minus 5. Then R2 minus 2 times R1, R3 minus 4 times R1. So the new matrix that we get is 1 to 1 first row as it is, and 2. The second row will be 2 minus 2, 0. Next entry minus 5, minus 3, and 2 minus 4, minus 2. Then the third one will be 0, minus 15, third one minus 9, minus 6. Again, I can see that the third row is just the second row multiplied by 3. So R3 minus 3 times R2. So what we get? 1, 2, 1, last one is 2. 0, minus 5, minus 3, minus 2. The last row will turn out to be 0. So the rank of A is equal to
2.
2,
2,
sir.
2.
which is also equal to the rank of augmented matrix. And our number of variables in this case are
3, sir.
3. Number of variables. So as per our method, system is consistent. System is consistent, and as the rank are equal and it is less than the number of variables, it has infinitely many solutions, and system has infinitely many solutions. Infinitely many solutions. Many solutions. So once we have infinitely many solutions, what I have to do is I have to declare a free variable. And how many variables I can declare free? So first of all, rewrite the equations. Rewrite equations. So what do we have? X plus 2y plus z is equal to 2 minus 5y minus 3z is equal to minus 2. Now, how many total variables are there? 3 minus what is the rank you have got? 2 is equal to 1. So 3 is number of variables, number of variables, 2 is the rank, and whatever answer turns out to be, these many free variables you have. Look, the dictionary meaning of free is the don't have any restrictions. It means that that variable, whichever is free, can take any value. That's why it is called a free variable. It is not restricted to 1, 2, or anything. It means that it can take any value. So you choose one variable from your last equation, any one, y or z, and put it as t. So z is free variable. So z is free variable. If in some example it turns out that these are two, so I will take two variables and free I will put as some other new variable. So z is equal to t, then y will turn out to be minus 2 plus 3t divided by 5. Then put this y and z in the first equation. Then put y comma z in x plus 2y plus z is equal to 2. So x will be equal to 2 minus 2 times minus 2 plus 3t divided by 5 minus t. By solving this, what we get is x is equal to, you can do the calculation, that will be 6 plus t by 5. This is your x, this is your y, this is your z. Now, my question is, how, I mean, you have got one value for x, one value for y, one value for z. Then how we are saying that there are infinitely many solutions?
Sir, we can
Sir,
put
as
Because
No,
sir,
just a
t
minute.
is the free variable,
T is a free variable.
so it
Daksh.
can be anything.
It can be anything. Yeah, exactly right. So you put t is equal to 1, you will get one pair of solution. Okay, you put t is equal to 1, x will become 7 by 5, y will become 1 by 5, and z will become 1. You put t is equal to 2, you will get another pair of solution. You can put t is equal to half, you will get third pair. So t can take any value, and which says that yes, here we have got infinitely many solutions. Take a minute, just revise what we have done, and then I will go for the next example. Fine. Solve x plus y plus z is equal to 4. 2x plus 5y minus 2z is equal to 3. So augmented matrix is 1 1 1 vertical line 4 2 5 minus 2 3. Then R2 minus 2 times R1. So 1 1 1, that is 4. Now 5 minus 2, it will be 3, minus 2 minus 2, it will be minus 4, 3 minus 8 is minus 5. So I hope this is echelon form. So in this, a rank of A is equal to 2, which is equal to rank of augmented matrix. So system is consistent with infinitely many solutions. Infinitely many solutions. So we will rewrite the equations. X plus y plus z is equal to 4 and 3y minus 4z is equal to minus 5. Now, what is the formula for number of free variables? N minus r are the free variables. What is our n? N is the number of variables and r is the rank. So n is equal to 3, r is equal to 2, so n minus r is equal to 1. You just have to declare one free variable. So put z is equal to t. Then y is equal to minus 5 plus 4t divided by 3. Then and x is equal to 4 minus in bracket minus 5 plus 4t divided by 3 minus t. So minus 4t minus 3t, so that will be minus 7t, and 12 and 5 17. So 17 minus 7t divided by 3. This is the value of x. Clear with this? So I'll simply ask you a small question and I expect you to answer it. Solve the system of equation. Solve the system of equations. X plus 3y plus 4z is equal to plus 12u is equal to 2020. That's it. Solve it. Who can answer this?
Sir, can you show the question once again?
Yeah, I'm so sorry.
So we will have to assume 3 free variables.
Who said it?
Yes, sir. Three
Uh,
free variables.
3 free variables.
Yes, sir, 3 free variables.
So 3 free variables.
Anirudh? Anirudh?
Yes, sir.
So which 3 variables? Why you want to consider 3 free variables?
Sir, because the rank will be rank of matrix is will be 1, and augmented matrix rank is also 1, but number of number of variables are 4 in the equation. So for the free variable we will subtract rank from the number of variables, so we will get 3 free variables.
Yes, very good. So what we will do here is, so augmented matrix is simply 1, 3, 4, 12. On the right hand side it is 20, 20. So rank of A is equal to rank of augmented matrix, which is equal to 1. So 4 variables minus 1, it will be 3 variables are free. So you put y as T1, z as T2, and u as T3. So x you will get as 2020 minus 3 T1 minus 4 T2 minus 12 T3. So you have infinitely many solutions, and this is it. Now you try one example. Two x plus 6y plus 11 is equal to 0. Then 6x plus 20y minus 6z plus 3 is equal to 0. 6y minus 18z plus 1 is equal to 0. Try this. So the augmented matrix is 2, 6, 0 minus 11.
Sir, wait, we are trying.
Yeah. Let me just write down the augmented. Minus 6 minus 3. The third one 0, 6, minus 18 and minus 1. Uh, that is that can be a silly mistake, so I just wrote the augmented matrix. Further you can try. Okay, before by the time you solve it, just let me know whether you know your roll numbers.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
We know our role.
Yes, sir.
Yes, sir.
Okay.
Excuse me, sir.
Yes.
Uh, the equation doesn't have the solution
Okay.
because the orders, the rank doesn't, the ranks aren't equal.
Okay. Fine.
Okay.
So the system is inconsistent.
Another one. Okay. Any other answer? Okay, I just want to let you know that whatever time you leave the lecture and whatever time you join, you can see it on the screen. The timing reflects here. So look at this. Gaurav Marathe, Ketan Singh, Mohit Bharadwaj. Those were here for only 8 minutes. Then further, Zain Khan, Yogesh, Vipul, Sharvil.
Sir, I am in the class right now. I'm in the class in the beginning. Zaheen.
Sir, I
Okay.
was also there.
Sir, me also.
Yes, sir, I was also.
Sir,
Yes, sir. I was also
I
there.
was also there at that time.
Sir, I was
So
there from the start beginning, but the because of network issue, I was rejoining again and again. But then also, I didn't see anything on the screen, and your voice is not clear.
okay. Look, so you have to be here. I mean, today I'm not looking at this, but after this, please make sure that you are attending the complete lecture.
So I'm also
Sir, please,
beginning only.
sir, please send the recording video because I
Yes.
didn't heard anything because of network issue.
Okay. Fine.